So thank you, Marco. Good afternoon, everyone. So before I start, I will ask you to put a mark on this map. So let's, now I think you can annotate, use the drawing toolbar on the left side of your screen. And so we all know where we are watching this weather briefing from. Okay, thank you. And I will continue now. So thank you again. So we have here we'll start by looking at the upper levels. So this is the water vapor 6.2, winds and geopotential at 300 hectopascal at 6 UTC. On the left side, so I think you can see the mouse. On the left side over the Atlantic, we have here a low pressure system southwest of Azores, and the ridge that is also northeast of Azores and goes towards northern Europe, as you can see over here. Over the Mediterranean Sea and southern Europe and also northern Africa, there is this large upper level low where it's easy to see the very intense jet stream. This area there have been some events related to severe convection, and so high winds, snow and heavy precipitation. The low has been moving eastwards and will continue to cause some severe weather during the weekend further east. So Eastern Mediterranean and also over the Black Sea. Also, you can see the mid-latitude jet stream over here. So with some frontal systems that are moving from Newfoundland towards Iceland and Northern Europe and continue further east. So they will bring some snow and rain over Northern Europe, high winds and also high waves. So here is the air mass RGB, which it's also at 6 UTC, and it's with mean sea level pressure, and it's a good RGB to analyze dynamic processes such as areas with stratospheric air intrusion, and of course the types of air masses. You can see here that the more or less cold air mass, this bluish color, is dominating, but we also have some air mass, this green color in the lower part of the image. You can see over here, over Africa, and some of this warm air is being advected over Eastern Mediterranean and Southeastern Europe. So the position of the high pressure you can see over the Atlantic and its ridge that is going towards north is bringing cold air over continental air or continental part of Europe and southern part of Europe. We have mentioned here some low temperatures over Europe and also over Portugal that we are not so used to. And this, of course, this differences between this cold air from north and this warm advection turn this area over the Mediterranean very unstable. And the frontal systems that I mentioned earlier that are moving north, we can see very well the high level cloudiness that is very whitish with some blue, very whitish color here. Of course, we also mentioned the the areas with maybe with stratospheric air intrusion or PV anomalies. There are mainly three areas that are interesting to monitor. So we have here the low level pressure here southwest of Azores with some dry intrusion over here. You can see also over near Morocco. Also here, it could be an area of convection. There was already some convection ongoing, and it could have some convection in the next few hours. And of course, over the Mediterranean, the mainly area over here, south eastern Mediterranean, but also other areas could have some active weather and convection due to these areas of PV anomalies. And of course, we also have to check the low-level features and it's better to use a different RGB, of course. So we have here the night microphysics RGB and the day natural color RGB. We still have more or less all area needs to use the night microphysics, but we still have this corner here. We can already use some the visible channels. So the stable area associated to the eye pressure system and the reach, it's more or less covered with low-level cloudiness. For example, we have here the stratocumulus sheets over the Atlantic, and we also can see some areas, some patches of pastel colors over continental Europe. So we can have here northern Italy, northern France, also in the Baltic countries, some little patches over Iberia. So these pastel colors have different shades because mainly it depends on the temperature of the cloud layer, and also depends on the thickness of the cloud layer. So it will be in different shades depending on these two things. So the thick, the high-level clouds that you can see here associated to the frontal systems, it's very thick with the red color, and also this dark blue, very dark blue, is this cirrus clouds, high-level clouds that we saw in the RGB. It's very with some white shades. So this is the dark blue. It's the very high level clouds. Also over Eastern Mediterranean Sea, I want to show this is a small, if you can see the small area here, it's gray brownish area. This is a dust layer. And the natural color RGB is better to detect low dust clouds over sea due to higher reflectivity of dust particles comparing to the sea. So we have here higher contrast. So it's better to use the day natural color RGB during over sea than over land. Over land we don't have contrast, and of course it's even better at low sun angles, so before sunset and after sunrise, due to the effect of forward scattering. And just to show you how active the Mediterranean area has been, for the past 2 hours, we can have here the convective rainfall rate from nowcasting south, and also the lightning. You can see this was more or less around 6 UTC, and it was already very active, and it has been since yesterday at least. Also, another thing I want to show you is the winds over the sea. There are some areas that we should monitor in the next few hours. So we can see here west of Iberia, a large area with high winds. And this is, you can see some cloudiness over here. This was a cold front that crosses Iberia yesterday. and behind it there is this area of high winds. So it's important to monitor this area from in terms of marine weather. Of course, this is from ASCAT B and C from the METOP satellite. And also this area, we have here several passes from ASCAT B and C from yesterday afternoon. And you can see there is some large areas of high winds, and these are generating eye seas and eye waves, and it's important to another area to monitor in the next hours and days, because the deep lows will continue in the next few days. And this is a different view from a different perspective of the low pressure system southwest of Azores. So this is a GOES East Cloud Phase RGB from yesterday. And this RGB will be available with MTG very soon. And the new channel is the near infrared 2.2 that is assigned to the green beam. And this RGB, to use only during daytime, provides microphysical information on cloud tops and the separation of water from ice cloud, and also information on cloud top particle size. So if we zoom in over the low pressure system, here are some examples just to get familiar with these colors and this new RGB. So the medium blue means thick ice clouds with large ice crystals, and the light blue, it's not showing here, but the light blue would mean small ice crystals. Another color is the pink. So the pink colors are thick water clouds, a light pink with small droplets, and darker pink will be larger droplets. We also have this kind of purple, and this would mean both mixed phase cloud or water clouds with extreme large droplets. So just an example, and to get familiar with this new RGB that will be available very soon. Okay, thank you. This was an overview of the current weather situation. Thank you. Nuno, you may continue.
Okay, thank you, Angela. I will now start sharing my part. So I will now pass to a second part of this briefing. So I will go back in time a little bit. So, and what I will talk to you is about monitoring the evolution of the flooded areas in the period from December last year until January this year. So let's say a little bit more than a month from now, because there was a lot of precipitation in some parts of the world, in fact. And so I will start with Sweden. I will start with the north. I will not start in Portugal this time. And so I will talk to you about this period between the 15th and the 22nd of January. And I will go to the southern part of Sweden. So this is the southern part of Sweden, and here is Denmark. So you have Copenhagen here and Malmo. So this is just to show you where we are now. I will in fact look a little bit closer to these lakes here, and one of them is here. This lake is, I will not try. Well, I can try, but I will not get the name right. Finjansjön, something like this. It's close to Hasselholm, and it's northeast of Malmo and Copenhagen. And there is a lake there. And in fact, there was this picture taken on the 16th, and well, I took it. It was in fact a period of holiday for me there, and I took this picture, and you can see here clearly close to the shore of the lake, a lot of flooded areas here. And then after having this picture taken, I was curious when I came back to see what the products on floods were giving. So in fact, I went to the global flood monitoring product of the observed flood extent. and tried to see if there was any flooding there identified by these products. And I checked for the 15th and the 20th, and there is nothing. So this is just the map that we have. This is location of the picture. In fact, there were no footprints on some days. So on the 16, 17, 18, 19, and 21. But then on the 22nd, in fact, there was a flooded area here in the north. So not on the area that I took the picture, but further in the northern part of this lake, or close to. In fact, when I was there during those days, there were some warnings of flooding, not in here, but in some parts of southern Sweden. So a lot of flooding, also resulting from melting. It was relatively warm. And so there was some warnings, as I mentioned, of flooding. So another area that I also looked at, it's a little bit to the southeast of that lake. It's another one. It's Lake Hammarsön, close to Kristianstad. On the 15th, there was nothing. And then also on the 20th, already on the 20th, there were some areas here in light blue again, is where the flooded areas are depicted. Also around the lake here, but not so close to the lake in this part. So, of course, this is the product that's called observed flood extent. And I will now talk to you a little bit more. But before that, of this product, I wanted to ask you just a question where now I have to try to annotate and let you annotate. I hope. Let me just a minute. Okay. So I guess you will be able to annotate in a minute. And so you can try to just choose the right question to this. The question is, which satellite and sensor are used to obtain the observed flood extent product in the global flood monitoring, the GFM of the Copernicus system? So you have a lot of possibilities here. So the first possibility is the METOP and ASCAT. And the second one is Sentinel-1 with SAR, synthetic aperture radar. The other one is Sentinel-2 with MSI, multispectral instrument. The fourth is Sentinel-3 with the microwave radiometer. So one of these is this combination of satellite and sensor is used to obtain the observed flood extent. So I guess you will now be able to tick your choice. I think you can do it already. So you had some time to think. So you can try to put, I see already 2 options. So please click with your. There is one of the first separation that you can take. That's either a METOP or a Sentinel. So I see we have 1 or 2 in METOP and ASCAT. We have 1, 2, 3, 4 in Sentinel-1 with SAR. We had just 1 in Sentinel-2 with multispectral instrument. We have a lot on the microwave radiometer in Sentinel-3. Okay, so I guess question mark. Okay, fair enough. So so let me just stop sharing then. We have already. I think there are 2 main options. One is Sentinel-1 with SAR, and the other is Sentinel-3 with microwave radiometer. Okay, let me just stop the annotation and move forward. So in fact, it was Sentinel-1 with SAR. So the synthetic aperture radar. Sentinel-1, it's a follow-on from the European Research Satellite 1 and 2 and the environmental satellite. In fact, this is a combination of 2 satellites. One was launched in 2014 and the other in 2016. And each satellite has a 12-day repeat cycle, exact repeat cycle. So every area is revisited around 6 days. Of course, this depends on latitude. But there is an alternating ascending and descending passes in the area. So this is the satellite, Sentinel-1, and the sensor is the synthetic aperture radar, SAR. It's a C-band. The frequency is 5.4 gigahertz, and the spatial resolutions vary between 2 and 40 meters, depending on the scanning mode on these level 1 products. And in fact, the GFM observed flood extent is 20 meters in terms of spatial resolution. And the other two things that it's important to take into consideration is that those results that I showed you before, they use a reference water mask, and this water mask is season dependent. So if an area is usually flooded in this part of the year, then the product will consider that and will not consider it as an additional flooding. And this could be what was happening in the south part of the lake, for instance. I'm not sure, but it could be an opportunity that we can explore. Another thing to take into consideration in this product, the observed flood extent, is that it's a result from an ensemble of 3 algorithms. They all compute independently if there is a flooded pixel or not. But the plotting and only exists if 2 detections. So if 2 algorithms are depicting a flooded area. So if there is just one of those, you will not have it, but it might happen. So this is something that you have to take care. This season dependence and the algorithm, the 3 algorithm issue when we are looking at the data. So this service, the flood monitoring, it's a relatively recent service. The first version started in December 2021, and there was 24 versions until the beginning of this month, in January 2023, so in the last 13 months. And there are some available products there. They are both available through the GLOFAS, the Global Flood Awareness System, or the EFAS, the European Flood Awareness System. And the products are regarding this list here: flood extent, some flags, satellite information. That can be very useful for flood monitoring after you have something. So, in fact, we had a month of heavy impact rainfall events in Portugal until the first week of January. Since the beginning, essentially since the beginning of December until the beginning of January. And so I will show to you a little going back, some of the big events that we had in the past. So I start with the most recent one. It was in Porto. It's the city here in the north of Portugal. On the 7th of January, we had a convective cell there that gave a 25 millimeter, not that high, this value, and in 1 hour and 40 millimeters in 6. This is for us an orange event. So this is the level, this circle here in the color, it's the level of the observation if for regarding the warning. So it was just an orange event in terms of what the automatic weather stations measured, but it was a very problematic situation because it was in the city of Porto. So we had many problems there. There was some issues with the construction of the subway that they have there. So it was a very problematic situation in Porto. Going back a little more, we had in the beginning, so in the first year of January, in the north, it's Vila Nova de Cerveira. It's here in the north, close to the border with Spain. There was the slow-moving active cold front, and there was a precipitation amount of 50 millimeters in 1 hour there. And in 24 hours, it exceeded the 200 millimeter value. So it was clearly a red in terms of observation. And it was also a very problematic situation. There is a village that was really devastated with this situation here. Going still a little more back in time, moving into December, we had in Lisbon 2 events. They were on the 7th and then on the 13th of December. There was first a squall line and then an instability line, which their axis was parallel to the displacement, and you know how bad it is. So we had, of course, as these squall lines and instability lines, very unstable air. The air mass was saturated from the surface, and with this displacement of the axis of the system being the same, we had really accumulated values of precipitation that were very problematic because they also happen over the city. So it was really over the city of Lisbon. So in the 2 events, they were both red in terms of observations. In 1 hour, the observations varied in the two events between 30 and 50 millimeters, and in 24 hours between 80 and 120, depending on the events. But this is the range just for you to know. The biggest thing here is that there were two red events in less than 1 week apart. So it was also a very catastrophic situation here in Portugal, and with a lot of impacts for sure. Also going still back, and it was maybe the first case that of this period that was very problematic. It was in the Algarve, so it all started in the south. It was in the beginning, 4th and 5th of December. Also two instability lines here, also with the same issue, saturated air mass, and the axis of the lines and the displacement were the same. So the parallel axis and displacement. Again, the values of precipitation in 1 hour between 30 and 45 millimeters, and in 24 between 100 and 110. So similar to what happened in Lisbon, but with less impacts, because it's not these areas here, although there were some problems, of course, too, but they are not, they don't have the same kind of structural issues as the city of Lisbon. So what I'm going to show you now is going back to this product on the floods extent, and to see what was the evolution between the 7 since the first occurrence until the middle of January in Lisbon and Tagus area. And so this is Lisbon here. It's in the center of Portugal, and this is the river Tejo here. This blue line. This is the usual Tejo path. And here's this big area where the river gets before arriving to Lisbon. And on the 7th, just before the first event, we had a couple of areas in blue. You see this blue here. This is the flooded areas depicted by this product. Also here, so we had a couple of things already because it had rained before. But after these two events, and we just had, of course, this new on the 13th, we could see a big change. So you could see, and I will toggle just for you to see. I will toggle again, and you can see the change of the area, flooded areas. Also here to the north of the Tejo, a big area here, and also here in Sorraia. This is another river that's a tributary to the Tagus River, and you see a big flooded area along this river here, and also to the south. Also, and you cannot see it so well, I put it in a different corner here. There is an area to in Loures, which is a city in the outskirts of Lisbon, with an area also of flooding, which you cannot see so much, but I will talk about this later on. So this was on the mid of December, and after 1 month approximately, we still had some areas that were flooded here. You can see also this Sorraia River in here, not in Lisbon. Of course, less areas, and I will toggle again. See, so the decrease until the 18th was such that at least some areas were still with problems. And in fact, some roads that were closed due to this flooding were still closed at this time of January. So after this time, after more than 1 month, there were some roads still closed because of this flooding. And this was ahead of this dry period that we are now experiencing, let's say. I want to show you also now the case of Loures, that small part to the north of Lisbon. I will just show now 4 images. This is on the 13th, so I remind you that the precipitation events were on the 7th and then on the 13th in the early morning, and this is something that we could already observe. So Lisbon, the city, the main city of Lisbon is somewhere to the south of this image. It's not here, but this is the big area that was with flooding. Then again, on the 26th, so on Christmas Day, there was already a decrease of this area. And then on the 31st, so the last day of the year, still an area with flooding. And only on the pass on the 6th, we could not see already nothing. So the flooded area disappeared between the scans on the 31st and the 6th. The scans are not daily, as I mentioned before. So with this product, you cannot really see a daily evolution, but rather, let's say, every 5 to 6 days or something, evolution. So just to end, I will just to share with you also this case in California, because it was not just in Europe that we had these floodings. California also experienced this since the end of December to the beginning of January. And just I just share with you a post from the Weather Channel on the 20th of January with these two. I don't know. I'm not sure if you've seen these or not on Instagram. With the change also between the 24th of December and the 9th of January, and you can see these big areas here that got flooded. And so this is just to really highlight that this issue is clearly worldwide. It's a worldwide problem. And this was the last thing that I wanted to tell you in terms of material. I just want to leave you with some references if you want to find something on the Copernicus Global Flood Monitoring. Also here a wiki for these products, the Sentinel link, and also for these California floods. You have some links here that you might want to explore. So thank you very much.